Hello, everyone. This is Gavin Mendel-Gleason. I'm the CTO of Terminus DB, and I'm here to talk to you about exploring the power of content knowledge graphs. So first, what is a knowledge graph? So at the Knowledge Graph Conference, of course, we have a lot of people talking about knowledge graphs, but in fact, there's no generally accepted definition. And we found that different people have different ideas about what precisely constitutes a knowledge graph. Um, Really, though, I would say it's a knowledge graph is a knowledge base with a graph structured data model. And so that can fit a lot of the various definitions that people have in it. So why use knowledge graphs? So of course, I think a lot of people who are here already have some idea of why they might want to use one, but I thought I'd just express what I've found in using knowledge graphs as against other kinds of systems. So I have a long history using relational database management systems before I became interested in them. So one of the things that really stands out is the ability to represent complex and sparse data. So if you have a lot of sparse data or you have a lot of relationships between a large number of things, relational database management systems can become unwieldy and quite difficult to understand. And the second thing is that relationships are really core to understanding information, and multi-hop relationships are very important in understanding what a thing is. So a thing is actually defined in many ways by the neighborhood around it, and we find that in all sorts of problem domains. And then the other thing that makes a knowledge graph a useful tool is the ability to use graph abstractions. So we can have classes, so we can represent a whole class of nodes and the different kinds of connections they have. And that actually tends to be quite difficult in most relational database management systems, and oftentimes you have auxiliary tables, etc., to try to represent that kind of information. So it's actually a very powerful and very general tool for solving problems. So now I want to talk a little bit about the knowledge graph lifecycle. So how do you get a knowledge graph? To get a knowledge graph, you have to go through various different stages. And once you've gone through those stages, it continues on as an ongoing project for a long time, generally speaking, if it turns out that it's useful. So the first entry point is often in what I call ingestion. So the ingestion of data that already exists, it could come from numerous sources, could come from relational database management systems, CSVs. So ingestion is really common. It's common to relational database management systems as well, often ingesting from previous relational database systems, from transactional systems, or some other source of information, because you don't want to have to do all of the data entry by hand. You often want to lift what you have available when you can. But the second part, which I think is less often thought about, is curation. So curation is the ability to update what you already have, either programmatically or with people. And so that life cycle is that once an ingestion has happened, it's not the only ingestion you'll probably do. You'll probably have multiple ingestions over a long period of time from different data sources as they become available, or as you enrich the model that you have. And then you will be able to curate this with individual humans, improving the information that's in there, correcting mistakes, or writing programs that help to improve the quality of the data that exists in your database. And then there's a final part, which is workflow staging, which is almost always built in a very custom way with both relational database management systems and knowledge graph systems as well. But I think it's a really critical part of the way that we have a data life cycle. So in the realm of code, we've treated this creation and maintenance of code bases very seriously. Almost everybody here has probably used Git to some extent if they've ever used any source code. Oftentimes people are using it outside of source code. They're using GitHub or GitLab or some other system like that in order to do revision control over structured information like code or even RDF and other things like that. So this kind of approach of having these repositories with the ability to branch, to do merge operations, has led to continuous integration and continuous deployment as a methodology of writing code. And really, it is a curation of code over time with the idea that certain branches or certain resources are kept in a state that is always usable while you try to do experiments or you have testing or other types of stages for the life cycle of the software in some other place. And then you merge them back into production or into testing or whichever phase you're entering into. Unfortunately, data has not really kept up with this approach of CI/CD. And to me, that seems quite strange because CI/CD is actually almost more applicable to data than it is to code. But we have a sort of weaker tool chain in that area. So let me just talk about ingest very briefly. So the ingestion of data from many sources it's common to almost all scenarios. And really, we want to be able to have a flexible data model in order to take information in as it becomes available to us, because you often have to have multiple sources. So you want some kind of data model where you can enforce integrity on the data model by saying what things are, what is allowed to go in, making sure you screen things for quality. But you also want to be flexible so that you can change it over time and make sure that you can evolve with your data over time. Then there's curation, and in many scenarios it's necessary for human operators to perform the data entry, and it can involve writing better descriptions for things, correcting errors that exist in your data, and you need some way to make this curation of the knowledge graph efficient in order to be able to have it useful. And the final part about staging. So in almost every process, many people have probably used some kind of content management system where there's an editorial control over the documents that go in, or they have some other kind of staging mechanism. Oftentimes with database systems, you'll actually have two systems and you add something to the one before it goes into production so that you can control or manage it. And sometimes you'll have human review processes, and the human review means an editor looks over the data to make sure that it's correct. But then there's also what we would call in the CI/CD world for code, custom linting processes. And these linting processes will look for both syntactic and semantic information to check to make sure that it meets certain kind of criteria. So for instance, if you're writing engineering manuals for Boeing, then you have certain kinds of restrictions on the language that is used. It has to fit within a more restricted, simpler version of the English language. So you could have a linting process that makes sure that all the documentation is automatically checked before you're ready to actually enter it into the main stream of information. And since oftentimes this information is now online, it could become available immediately. If we don't have some way to automatically merge back after review, it can be quite an onerous step that involves custom work. So this is why I think that data should look more like Git than it has our current relational database management systems or many of our graph databases as they exist in the world at the moment. So I'd like to just show you briefly how this works so you can get an idea of what it looks like in practice. So, okay, so I'm going to go over to Terminus CMS. So you can come to terminusdb.com and you can sign up and get a free sign-in for this if you would like. And I've just gone ahead and created a new data product. You can also clone data products. That we have some demo data products that you can look through yourself. You can clone it, and cloning is a very fast operation. It's similar to Git in that you don't have to reconstruct the entire database on our system, you can just copy over a pointer to it. So let's look at this simple data product called example people. So the first thing is there's only a few different classes in this database: pets, people, and organizations. And we can see this is a sort of JSON representation in JSON LD of what is in this structure. So what we're allowed to enter into the database. So we have pets. Pets have a name. The name is a string. We have people. A person has a comment, a friend, a name, and a pet. And then we have organizations, and the organizations have a set of people which are in them. So if we would like to, we can go here and we can browse through the different things that have been added. So I have added 3 people and 1 pet so far. So if we go to the people, you can look in, we can open John Doe. You can see a summary view of what John Doe is. You can see that he's pointing to some other people. These people, you can pop up and look at them. You can follow through in sort of a linked data mechanism. However, we can also edit this record, and when we edit this record, we get a new change request started automatically. So we could say, I'm going to edit a record. This is a record. Start a change request. Now I'm in the edit view of this. So in this edit view, I'm able to add some information to the comment. I could change the name of John Doe to John Doe Jr. And I can even add a pet to him. So I can either create a new document or link to an existing one. I'm just going to make a new pet, and it's called Tiger. It's going to be the name of his pet. And then I can submit this document with my edits, and it gives me back a screen that shows the overview of this here. Now what I have done here is not edited the actual main database. So this has actually gone into a branch. It's a change request. So this change request, I can go and I can say it's ready for review. I'd like to see the review. And then someone can then review the changes that are made. So supposing I'm the editor, I can go into review the changes, and I can see here that I have a number of different diffs on different objects. So one is a change from John Doe to John Doe Jr. Here I see the comment has changed between the two, and indeed I've added another pet. And this is just a pure addition. So there was nothing previously, but now in main there was nothing, and now in this branch here we have Tiger. And if I like these changes, then I can accept them and approve. This looks okay to me. This will go into a comment database that can then be retrieved later, and the information is actually merged into the database. Now you can see we're no longer in a change request. We're actually back on the main branch. Now you can always change branches if you'd like. You can even go back in time and see what it was like previous. So we can time travel to some other point that's not the latest point, or we can go back to head to see main. And if we go to the most recent changes again, we see now we have 2 pets, and we've altered the information about John. And so once you've done all of this, you have the information in your database. You can also query it very easily using GraphQL. And because the data model describes what's in here, we can automatically construct queries in GraphQL so that these queries are available for all of the kinds of classes that you've described. So in this case, I have a comments field on person. I also have pets as a possibility, but a pet is also an object with a name, and we probably also want a name for our person to be able to see what's in it. And then if you do the query, you get the answers back in the usual way from GraphQL, which is quite cool, I think. But in addition to that, we have some other things. We can see backlinks very easily. So you can see the friend of person. You can see who was pointing to you as a friend. So you get a backlink automatically. Everything has a symmetric reverse direction. So there's path to organization, members of organization, so you can go in both directions. And we also have a path operator. So the path operator allows you to do long chains or multi-hops along. So that gives you sort of an idea of the general mechanism. So the change request structure, you have all of the change requests that you have opened, reviewed, merged, or rejected are listed here in this area. And you can even see what has previously been merged, and you can see the approved diffs. You can go back and time travel. So all the states of the database are available. And one might think that this is very expensive. Could you actually do this with large amounts of data? But yeah, it's quite possible to do this because we use a very compressed format for all of the changes that are made. And then we have indexing structures that work over those changes. So for instance, if we go to the nuclear data product, we have quite a lot more things in it. And you can see also, you can go in, edit these sorts of complex structured documents. You can also see maps that give information about what they are. And we're able to render GeoJSON, so we have the ability to do mapping as well in these structured content views. And finally, let's see if I have a example team. Just quickly, we have the ability to clone a data set. So the clone of the Lego data set is kind of interesting because it pops up almost immediately, and the number of documents in here you can see is quite substantial. So it's kind of interesting that a clone or branching is such a quick operation, even with tens of thousands, hundreds of thousands, or even millions of documents. Okay, so that brings me back to my conclusion. So what I've tried to include in Terminus CMS as much as possible are these ideas from CI/CD, branching, change requests, revision control on knowledge graphs. And we want to make it perform really well on very large data sets so you can get really proper knowledge graph scale into it. And I think it solves a lot of problems that arise in practice on knowledge graph use cases. So we're trying to combine the state-of-the-art approaches for knowledge graphs with these sort of CI/CD approaches. And I'm hoping that we can take data management out of the dark ages and join the CI/CD revolution along with code. And that's it. So does anybody have any questions?
Thank you so much, Gavin. That was great. We have a question from Mariana. Hello, Mariana. Is it possible to perform changes in bulk in what you described?
Yeah, absolutely. So all of these changes that are made through the interface are actually using our API. And so the API is, we have bindings. It's actually a RESTful API, and we have bindings in Python and in JavaScript. And you can do bulk edits, you can do bulk insertions. All of the conflict and diff information can be processed programmatically. So we actually return a JSON that describes all of the changes between the documents, and then you could process that in some sort of automated way, if you like. Sorry, Aaron, I think you're on mute there.
Uh,
No,
that's only been said to me a million times in the past couple of years. Yes, off mute. Thanks, Gavin. Yeah, with regard to data being a second-class citizen to code, do you think, to what degree do you think that this might be related to stakeholders' understanding or lack of understanding in a content context that data itself is a part of content? Um, that is, do you think it's widely recognized that it is such, or is content in kind of the traditional content management world too narrowly framed as editorial content?
yeah, I think that's very common. So one of the things that I found is that there are a lot of these problems where people have very complex data that they need to manage, and they don't have, like, CMSs have gotten very good at relatively simple data management problems. And some of the headless CMSs are moving in this direction to very complex, rich data management scenarios. But there is this, belief that either, you should treat data I guess you give it to coders, and the coders tend to treat the data as second class citizens, or you give it to people who just do data entry, and they just treat, they use a CMS because it's the best sort of interface that they have available, and it works pretty well up to a point, and then at some point it really becomes overloaded and too difficult to manage the data models.
Thanks. Another question, this from Dan Howarth. Hi, Dan. How do you find getting data engineers and content people to understand each other? Kind of a knock on for me. There's a niche thing for each of those roles, and this conference is about the only place I've seen us come together: data engineers and content people.
Yeah, no, I think that's it's definitely true. It's sort of a difficulty that we have to overcome, and I think maybe we need to discuss that more openly as a sort of a core problem. That this is a space that has to be treated as a real data ops, data engineering. These sorts of things have to be seen as really central to the kinds of things that people are providing, because managing data is becoming ever more important in enterprise. Like, almost all companies need to have better understanding, visibility, management. All of these things are critical to operations. So if we don't get better at it, then we should learn to talk about it, I guess. Learn how to promote it.
Yeah, plus one to that, Dan. Certainly my intersections, semantic and structured content. It's still rare to see, especially content strategists, kind of delve into this world. And I'm opinionated, but I think to the degree that they should, to understand not just the kind of traditional slice of content strategy, but that part of that strategy needs to be, oh, what sort of data do I have available to manipulate in a content ecosystem and use it as such, and what engineers do I need to be talking to, and what data flow.
Yeah, I totally agree with that.
Cool. So I don't think we have any further questions at this time. I know it's about time for a break there in New York. So thank you, everyone, for attending this session. Thank you so much, Gavin, for that great talk. And
Thanks very much for having me.
all around in the interwebs. Take care.
Great. Talk to you later.